Hi everyone, welcome to Underview Learning Space. So today we'll be looking at chords. Now what is a chord? A chord is simply a straight line that is drawn on from one point of the circumference of a circle to another. So let's assume we have a straight line this way from one point on the circle to another. This line, let's call it A, B. Now, line AB here is said to be a chord with that center. Let's call the center O. So, this is line AB, the chord. Good. Now, when we have a chord and there is a perpendicular drawn from that chord, what is a perpendicular? It's a straight line drawn in such a way that it intersects with another at 90 degrees, just like we have it here to be. This line PQ, a perpendicular to it, is 90 degrees. So this line AB now, which is the chord, if we are to draw a perpendicular in such a way that to pass through the center of the circle, it will divide the chord, which is that line AB, into two equal parts. This is the perpendicular. Are you following? So this this is the right angle, which means that line, that straight line, and is the line that shows the distance between the chord and the center of a circle. These ones I'm drawing in blue now are the radii. Those are the radii from point A to point O, which is the center of the circle. So when you have a problem like this, please, whenever you have problems on chord, in order for you to have a clearer and a better understanding, you first of all draw it. So that's point O, which is the center of the circle. So line AO is the radius, AO and OB, and then line AB is the length of the chord, and line ON is the distance between the chord and the center of the circle. So let's draw out the triangle so that we'll understand it a lot better. So this is point AB and then point O. Good. This is the triangle and point N. So you can see that AON has given us a right angled triangle and BON as well has given us another right angled triangle. So when we have problems like this, what we apply is Pythagoras theorem or trigonometric ratio. So this is the radius, this is another radius for AO and OB, which are the longest sides of the two triangles as drawn below respectively. So let's quickly look at a question which says that a chord 18 centimeters long is drawn from a circle of radius 15 centimeters. Calculate the distance between the chord and the center of the circle. So first let's draw. This is the center of the circle. This is the chord and the radii. Good. So mind you that we have a perpendicular which shows the distance between the chord and the center of the circle. And the length of the chord here is 18 centimeters. So we divide it by 2. We divide that 18 by 2 because that perpendicular divides that chord into two equal parts. So 18 divided by 2 gives us 9 centimeters. So the distance between the chord from the circumference to the point where it intersects with the line that shows the distance between the chord and the center of the circle is 9 centimeters and 9 centimeters respectively for the both triangles. So, and the radius is, or the radii are 15 centimeters each. So this 15 centimeters and 15 centimeter. Very good. So we are looking for the distance between the chord and the center of the circle. So let's call it X. So having a problem like this, these are the right angles, which shows that these are right angled triangles. So let's have enough space to solve our problem. So here, let's write out the givens. First, we have the hypotenuse, and the hypotenuse is given to be 15 centimeters, 15 cm. And then our opposite, let's call it x, is the unknown. Then our adjacent is 9 centimeter. Sorry, I'm abbreviating them, hypotenuse, the opposite, and the adjacent as well. 9 centimeters. So let's impute this into the Pythagoras theorem, which says hypotenuse squared equal to opposite squared plus adjacent square. So let's impute those values in this formula to solve for x. So our hypotenuse is 15. Therefore, let me change the color of the ink to black. So, sorry. Okay, thank you. 15 squared for the hypotenuse equal to x squared for the opposite squared plus the adjacent square, which is 9 squared. So 15 squared will give us 225 equal to x squared plus 9 squared will give us 81. So from here, let's collect like terms and rearrange. So x squared is equal to 225 minus 81. And 225 minus 81 will give us 144. So x squared is equal to 144. From here, we take the square root of both sides to find the value of x. So square cancels square root. X is equal to square root of 144 is 12 centimeters. Therefore, the distance between the chord and the center of the circle is 12 centimeters. So we can actually include that in our diagram now. Let's zoom it out. So let's erase this x. You can leave your value to be x there in your exams and it won't cause any harm, please. I just want to impute it here so that you get a clearer and a better picture of what we are talking about. 12 centimeters. So this is the distance between the chord and the center of the circle. So this is the distance indicated in red. So please feel free to share this video, like and comment and refer others, share it until it goes viral. See you in class next time. Bye.